Alright, let's take a look at an exponential decay function and writing an exponential decay function. Well, like we saw before, a general exponential function will be in the form of f of x is equal to a times b to the x, where a is the starting initial value when x is 0, and b is the constant multiplier. What are we multiplying by repeatedly? Now, we used this form before when we were talking about exponential growth, and we're going to use the same form to talk about exponential decay. What changes this from growth to decay is the fact that this value b has to be between 0 and 1. If that is true, if you're multiplying by a number that is between 0 and 1, the values of the function are going to be decreasing because you're multiplying by something smaller than 1. So let's take a look at this in action here. If I take some number, I'll start with 48. Let's throw that out there. 48. So if I'm taking the number 48 and I'm going to be multiplying that number by something smaller than 1, so let's say times 0.9. Then I started with 48, now I have 43.2, 38.88, and that value is consistently decreasing because I'm multiplying repeatedly by a number that's less than 1, so it's getting smaller and smaller. That's what exponential decay is all about. Now, this is eventually going to approach 0, but never quite reach it. So let's take a look at writing out an exponential decay function. So here's my first example. It's going to involve depreciation of value. So Toby bought a 2015 Honda CBR 250R motorcycle for $5,600. Each year its value will depreciate by about 12%. What that means is that every year that goes by, the value the motorcycle has is going to decrease by 12% of what it was before. So using this form, we would need to know what the constant multiplier is. So it is decreasing by 12%. Well, if we use this other form, f of x is equal to a times 1 minus r, since we are decaying, it's decreasing in value. Well, let's see, what did he start with? He bought the motorcycle for $5,600, so a would be $5,600 times 1 minus the depreciation amount. It is losing 12% per year. So we're showing 1 minus 0.12 to represent that it is losing 12% every year. So we're taking 5,600 times 1 minus 0.12 to show it's losing that value. And that is raised to the x. So there's our exponential decay function. My next question is, what will the value be after 5 years? Well, here, x is going to represent the years that go by, because every year that goes by, you're multiplying by this amount, and so we're multiplying each year, so x is an exponent. F of x here is going to represent the value that the motorcycle has. So we're looking after 5 years, so x must be 5. So we're going to look up f of 5, and that is 5,600 times 1 minus 0.12 raised to the 5th power. And if you calculate what that is, that will be about 2,955.30 cents. So to recap, what we've done with this exponential decay function is we still needed to use this same form. It's really similar to the growth. The only difference here is b is less than 1, or we're subtracting because we are decreasing by a certain percent. So a, the starting value, was $5,600. That's what he bought the motorcycle for. R, the depreciation rate, was 0.12, and we're subtracting it because it's losing that value. F of x stays f of x, and x is a variable, and that allows us to substitute values in to make calculations. The next question was to find the value after 5 years, so that meant that x would be 5. Substituted 5 in here, and worked out what this would be, and it turned out to be about 2,955.